Guys, I was going to make a video to help you with number 10 on the worksheet that's due today. So in your calculator on Desmos, the first thing you have to do is put your data into your table or into L1, L2 like we've been doing. So I'm going to go ahead and take this data from number 10 and do that. So I'm going to go into Desmos so you can see it. And I'm going to put in a table. And for number 10, the x values were 0, 9, 1, 8, 15, 3, 12, 5, 6, and 10 for the hours spent watching TV. And then the corresponding scores on the test were 100, 78, 98, 80, 52, 95, 69, 88, 86, and 73. So again, I don't see a scatter plot, and we've talked about this many times. You have to fix your window. So either in Desmos or in your calculator, you need to fix your window so that you can see your data. So I'm going to go from -5 to 15 on the x because my x's go from 0 to 10, so a little bit below and a little bit above. And my y's, I'll go from maybe 69 is the lowest. So 52 is the lowest y value. So maybe I'll go from 50 to 105, and maybe I'll go by 5s. Okay, so if you look at this scatter plot, it looks like a line, so linear regression may be the best fit in that case. But if you remember, I gave you that reference sheet, so that should also help you. When you look at the scatter plot, if it looks curved, then a line may not be the best fit. And we'll have to check our correlation coefficients or our R values to see what model is actually the best fit. So to do a linear regression, I would type in my y, and remember, if you don't have a calculator to do it in Desmos, type your y1 and that approximately button that I showed you in the other video. So if you need that video, you can go back to that. So if I look at this one, it says the R is a -0.985, and A is -3.025, and B is 102.778. So the -0.9851, the R value being negative, just means this is a negative correlation, which means as one increases, the other is decreasing. So the more hours you spend watching TV, in general, the lower your test score. Okay, so I'm going to need to keep that in mind, and it also said for number 10 to try linear, quadratic, cubic, and exponential. So to try quadratic, that reference sheet may be helpful again, but quadratic, remember, is ax squared plus bx plus c. So I would put in y1, because if you type it in Desmos, you always have to have, so y1, approximately ax with the 1, and then I will need to square that, plus b x with the 1 plus c. Okay, so if you look, actually in this case, the R squared, or the correlation coefficient, is 0.9929. So that's actually a better fit than the line, because you see it curved and you see it closer to the points that the data, it goes through some of the points actually on the scatter plot. So actually that quadratic regression right now is a better fit than the linear regression model, because its correlation coefficient was -0.985, which is close to -1, meaning it's a negative regression, but 0.99 is closer. It's a stronger correlation. So then it said try cubic. So if I wanted to try cubic, remember cubic is ax cubed plus bx squared plus cx plus d. So I would type in y1, and you could do this in your calculator, is ax1, and this time I'm going to have to raise that to the third power plus b x1, and that's going to be squared plus cx1 plus d. Okay, so if you look at that, this says that my r squared, or my correlation coefficient in this case, is 0.9945, and that's actually even closer than 0.992. So right now the the cubic model is the best one for this data because it has the highest correlation. So finally, I said try exponential. So if you remember, my exponential was y1 is approximately a, b, and that's raised to the x power. And whenever you do it in your calculator, you have to do this sub 1 because your table has y1 and x1. And it says r squared is 0.94. Okay, so that means in this case our cubic model is the one that has the strongest correlation coefficient, and that's in blue. So if you see this blue line, okay. And actually it's pretty close to the quadratic model anyways, because if you notice that A is really, really close to 0. So when you go to make your predictions, okay, you would use the model that is the best fit and plug in your x value to figure out the y value. So if you're going to use the cubic model in this case, so my equation is the y equals, and remember, in place of your a, you'd be putting in your negative 0.007 x cubed. So I'd have negative 0.007 x cubed plus, and in place of b with the cubic model, it's 0.057, so I put 0.057 x squared plus, and in place of c, it's negative 2.48. So I could either put plus a negative or just minus 2.48x. And then finally, in place of d, d is 100.486, so I put plus 100.5. Okay, so that's my equation. If I want to predict, it says use the regression equation to predict the y value for each of the given x values. So the first one says x equals 2 hours. So that means everywhere I have an x, I'm going to plug in 2. So I want to say, in place of my x, so I'm going to have my negative 0.007, and I'm going to plug in 2, and I'm going to cube that. And then I'm going to take, 0.57, and in place of the x, again, I'm going to plug in 2, square that, minus 2.48, and in place of x, I'm going to plug in 2, plus 1. Sorry, it's 100, it's not plus 1, it's 100.5. So that was your d value. So the prediction is that if I watch TV for 2 hours, I will get about a 97.764 on the test. And that should make sense because when you go back and look at your data, at 1 hour the person got a 98, and at 3 hours they got a 95. So if I were predicting for 2 hours, my answer should be somewhere between those two. All right, so hopefully that helps you as you try and complete the assignment for today. Thank you.